Okay, this is chapter 3, and this is considered advanced functions. Do you remember when we found inverses of things? That was in this chapter. Now, we've practiced that a few times since, so I think it won't be that bad. But let's say that I gave you this equation, y equals 2x plus 7. I'll keep it fairly simple and say just divided by 3. Then that's a function, right? It has an inverse. Try to remember how to find the inverse of that function. If I called this f of x, just a reminder, then inverse would be f like that, f to the negative 1 of x. Pause for a second while you find that inverse. Okay, so you should have said that you replace the f of x with a y, and y equals that, and then you swap the x and the y. So we say x equals 2y plus 7 over 3. Raise your hand if you started that right. Okay, good. Next, we're going to solve for y. I'm multiplying by 3 on both sides. I am subtracting 7 on both sides. 3x minus. Tried to do something, I should just do it the old-fashioned way. There we go. And then I'm dividing by 2 on both sides. And there is my function, 3x minus 7 over 2. Raise your hand if you had that one right. That was the what? The inverse. And that means that every x and y combo got reversed. So if I gave you a picture instead and said, I'd like to know the inverse of that, try to sketch for me what the inverse of that looks like. Every xy combo, like 2 comma 8, becomes 8 comma 2. In case you've forgotten, what I just graphed for you there was roughly log. You remember log is like a tree blown over in the wind? And the one that's an inverse of it is the exponential function, which goes like that. If you had to, you could always draw in the line y equals x and make it every point get reflected across that line. Like for instance, you could make up a point and say, well, that looks to me like about 5 comma 2. If that's 5 comma 2, then what must be on this one? Over 2 and up 5. So my green line is actually off a smidge. Probably would have done better instead of just rough estimating to actually take points like that and say, okay, so there should be a dot like right there. This dot right here, which looks like, maybe it's a log that's been shifted over because it doesn't look like it's going through 1, but let's say it's going through 2 comma 0, then it should be at 0 comma 2. That and the red one are inverses of each other. They are a reflection across that dotted line. And because it's kind of sideways, that messes with everybody. If I asked you to do a reflection across the line straight up and down, everybody can do it, no problem. All right, so just main thing, if there's 5 comma 2 in it, then it has to have 2 comma 5 on it. The x and the y is the reverse. So what does that mean about the domains and ranges? They're flipped. So if I ask you to find me an inverse, like this on this other one, and you got your inverse, and I ask for the inverse's range, should you like go draw a picture of it? No. You should go back to the other one, and if I want the inverse's range, I really want the original's domain. And if you wanted to know the domain of this one, that's in a different chapter. Domains is the main place we handle that is in chapter 2, so you should watch the video for that. All right. Generally speaking, I'll just remind you quick, the domain here doesn't have any square roots, and there's no way to crash it on the bottom, and therefore this is an all reals domain. Okay, but if you need more work on domains, go back and watch chapter 2. So your next thing is, let's say that I have 2 functions, f of x and g of x, and f of x is going to be this, square root of x plus 4, and g of x is going to be 1 over x minus 3. Would you please tell me what f of g of x is and what its domain is? See if you remember that. I'll pause for a second while you do that. Okay, quick reminder on how this works. The g needs to get swallowed by the f function. So here's the f function. I make the f function with a big empty stomach where the x used to be, and I drop in, instead of x, 1 over x minus 3, and that's good enough. You don't have to have that all simplified out. That is f of g of x. Now, what's its domain? What's its domain? You do not look at this guy and figure out its domain. Do you remember the formula? This is the something, d of something intersected with something in something. Ooh, maybe you have something that you should remember for the test. That's good reason to be watching this video, okay? So it's the domain of the inside, which in this case is g. Again, if I swap the f and the g, you'd have to do a different one. But the domain of the inside intersected with f of x, the other function, in the domain of g. There's your go-to money function. Now let's go look at these guys' domains. The domain of f here would be what's underneath here. X plus 4 has to be bigger than or equal to 0. So x has to be bigger than or equal to negative 4. That's the domain of f. How about the domain of g? The domain of g is that what's on the denominator cannot be 0. So x cannot be positive 3. We're down to 12 minutes left. That's okay on a day like today, because you're not going to have any homework assigned for today. So I'm going to go right up to the end of the hour with this chapter 3 stuff. Okay. So now I'm going to take the domain of g, which we just found is right here. X cannot be 3. X cannot be 3. It has to be intersected with f of x in d of g. Here's f of x, square root of x plus 4 plus in d of g. Here's d of g right here, and I got to put this into that. Where can I put it in? Where the x is. So I say is not equal to 3. You just happened there? This formula you have to memorize. Then f of x is the normal function, not the domain of it. Goes into the domain of the other function. So this needed to go into this. And you put it right where the x is. Now I just need to solve this. I still have x is not 3 intersected with the square root of x plus 4. Okay, not equal to 3. So I'm going to square both sides. X plus 4 not equal to 9. Subtract 4 from both sides. X not equal to 5. And now I overlap x is not equal to 3 overlapped with x is not equal to 5. And the way I like to overlap or intersect things is I like to make two number lines. Here's where 3 is, and this is that first number line where it can't be 3. Here's the other number line where it can't be 5. Now, where do they overlap? In lots of places. This zone, which is from negative infinity to 3. This zone, which is between 3 and 5. And this zone, which is where it's bigger than 5. You did this. You passed this test, most of you. Question is, can you remember it when the time comes? So this kind had a formula. The other kinds are simpler. Go back to f of x equals, let's make this square root of x minus 9, and let's say g of x is 1 over x plus 2. And the other ones, if I wanted you to just do f of x plus g of x, it's just that plus that. If I wanted to do f of x times g of x, it was just this times this. And add, subtract, or multiply f and g, all you had to do was take the two parent functions and overlap them. Domain of f and domain of g. Here it's x has to be, x minus 9 has to be bigger than or equal to 0, so x has to be greater than or equal to 9. And here I have x plus 2 cannot be 0, so x cannot be negative 2. So here's my two domains. Domain of f is bigger than 9. or equal to 9. The domain of G is not equal to -2. Here's -2. And it can't be that, but it can be everything else. Do you remember how these just had 2 number lines and you could just overlap those 2 number lines? The domain of any f plus g of x or f minus g of x or f times g of x is just take the 2 parent domains and overlap them. In this case, its x is bigger than 9, bigger than or equal to 9. All right, and there was one more kind that I haven't showed you yet, and that's f of x divided by g of x, or f over g of x. When you divide 2 functions, you have 3 number lines to check their domain. You have the domain of f, which is bigger than 9. You have the domain of g, which is not -2. And the third number line, because this is divide, do you get we can't let that g be 0? Do you remember that one? You can't let the g function be 0. So you look back at your g function and you ask yourself, what would make the g function 0? Is there anything that would make the g function 0? Nope. Nothing can make it 0. So if nothing can make the g function 0, do we really have to worry about this thing crashing because the g function is 0? No. So we don't need this third number line in this case. But in a normal, here's another way we could have done it. Let's say that this function had been x over x plus 2. Then what would make it equal 0 is if x equals 0. Then you'd have to add in this extra requirement that it can't be that. And then you'd see where all the number lines overlap, which would be right there again. That's where all 3 of them overlap. But that's, again, if I change the problem. In this particular problem that I had, g of x couldn't equal 0. So to see if you really understand that, would you try, I'm going to reverse these and say not f over g, but g over f of x. I don't need to even know what it is. It's just the one divided by the other. It's easy. But what's its domain? This one, the bottom function can be made equal to 0. So try to find the 3 number lines that overlap. The first one's the bigger than 9 thing. That's domain of f. Domain of g can't be -2. And the third one, what makes the f function, that's this function now, what makes it equal 0? If x is 9, here's 9, it can't be allowed to be 9. Otherwise, it'll crash the combined function here if the f function was allowed to be 0. So now where do all 3 of them overlap? Just after 9. So x is greater than, not or equal to, just x is greater than 9 would be the domain of this function. All right, so that was a lot of chapter 3, but not all of it yet. How do you prove 2 things are inverses? If f of g of x is equal to, do you remember? G of f of x. That's how you prove that 2 functions are really inverses of each other. So we're going to do it with 2 super simple ones. Y equals 2x plus 3, and the inverse for that, which I'll make really quick, x equals 2y plus 3, and then subtract 3 from both sides. X minus 3 equals 2y. So x minus 3 over 2 is the inverse for it. I already know these 2 are inverses, but I'm going to prove it. I would say f of g of x has to equal g of f of x, and do you remember what they both simplified down to at the end? X. They will both equal x at the end. Why don't you give that one a try and prove that this function and this function are inverses by sticking the one inside the other and vice versa. I'm going to put the g function here. Let's call this f of x. Let's call this g of x. This one goes inside this one. I always drew these with the line down the middle. And remember me saying, a kid who goes like this, do. Of course, it looks like they all cancel and it's just X, but that's not showing me you know what order they cancel in. The order is a big deal. Okay, so then what can be done first? These can get canceled first because of the order of operations. Your multiply has to be done before you add and subtract. So then you're down to x minus 3 plus 3. And then now those can be canceled and it does equal x. Cool. I didn't prove it yet because I have to go the other side. G of f of x means I start with this function right here, empty spot minus 3 over 2, and then I'm going to drop in this function, 2x plus 3. And then what can be done first? In this case, I have to get this top part done first in a fraction because there's parentheses up there, and parentheses have priority. So the plus and the minus 3 cancel, and I have 2x over 2. And then I can cancel those 2's, and it equals x. Cool. X equals x. I have proven two things are inverses. All right. Let's say we had this, and that's a 1 over x. I'm going to just do one last thing for you because I think it's important. Would you know what to do if I said inverse of f of x plus 2? Well, first I'd have to figure out the inverse of f. And then what would I stick into it? X plus 2. All right. What if I did inverse of f of g of 2? Well, always start on the inside of these things. What is g of 2? Stick it in there. It's 1/2. So this is really inverse of f of 1/2. And then I have to find the inverse of this function and then stick a half into it. Okay, I think that pretty thoroughly covers the stuff you'd need to know from chapter 3. You see why I'm not trying to do all the chapters on once? All right, that's all I got for you for today.